Okay, Facebook is live. Okay, welcome to the second part of the talk. Okay, last Tuesday we covered for questionnaire validation for dichotomous data. Means dichotomous means whether the person got it right or whether the person got it wrong. Okay, so today we're going to cover about polytomous data. So when we say polytomous data, we are referring to things like your uh, what you say, your Likert scale. Okay, you're asking the person, are you happy with the lecturer's approach to online learning? So you answer agree. So the scale is 1, 2, 3, 4, 5. Strongly disagree, disagree, not sure, agree, strongly agree. So that is ordinal data, Likert scale. Okay. So for that is what we call polytomous data, polytomous response. So today we're going to cover on such questions, such skills. Okay. So hopefully you all can follow. Please take note, these notes were prepared with the Peramal. Peramal short for Persatuan Rasch Malaysia. I'm just an associate member. Okay. But the group is very well led by this group of Rasch expert. And whenever they run courses, I suggest that you do check them out and attend their classes. They're very good. They are very good. Okay. So this notes also has two parts. The other part came from the lectures from Prof. Prof. Ayub, also known as Prof. Lin Nang. Okay. So there is some overlap because we are covering both the classical test theory, which is exploratory factor analysis, and the item response theory. In this case, we are doing Rasch partial credit. Rasch partial credit. Why they call it Rasch partial credit? Because the scale that we use got two kind of scales. One scale is based on 5. Another scale is based on 3. Okay, so that's why it is called Rasch partial credit. Okay. Okay, so let's not worry about that. Okay, let's go to the next part of the lecture. Okay. So usually whenever you have a questions to measure something, okay. Here, okay, Azira saying something. Azira kata apa tak nampak apa?
Prof,
Ya. Yeah.
screen Prof nampak yang Prof naik basikal.
Subhanallah. Okay, kejap Nampak saya naik basikal Tapi dekat saya punya ni, dekat saya punya saya nampak yang apa, yalah dekat saya nampak yang saya background yang apa benda tu. Tapi you all nampak saya naik basikal kejap Oh, ya tak ya. Kejap Thousand apologies. Baik kau cakap. Sekarang virtual camera off. Terima kasih.
Share slide lagi.
Okay. Tak ada ni masalah bila ngajar dua kelas. Ngajar dua kelas dia satu kelas dia nampak, satu kelas tak nampak. Okay, now I already set for both classes. Okay. So are you seeing my slide already?
Yes, Prof.
Okay, so I'm going to set. Tak ajalah kejap I set okay, don't worry. Kejap lagi I besarkan. Dia akan clear. Kejap I besarkan. Oops, sorry. Okay, dah clear?
Okay, Prof.
Okay, Prof.
Okay, nampak Alright, thank you. So very sorry about that. Okay. Yalah, cita-cita tinggi. Nak buat, nak ngajar dua-dua. Dapat ujung pangkal lesap, dapat pangkal ujung lesap. Alright. So very sorry about the interruption. Okay, again I repeat back. Okay, whenever we have a questionnaire like quality of life, when we're trying to measure something, usually we ask questions based on ordinal scale. So we came up with a statement, and based on the statement, we ask the patient or the neutral score is 3. Okay. So when we have this kind of scenario, ordinal scale, we have to validate and make sure that you are really measuring what you're trying to measure. Okay. So for that to happen is, here an example. Okay. This is a questionnaire on quality of life. I think you know which questionnaire is this. I'm not going to state it out. Okay. I don't want to get sued. But basically, there are 36 questions here. Okay, 32. There are 36. There are 36 questions here. And all these 36 questions are asking different things. Yeah, asking different things. For question number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, they are asking question about physical function. For question about 1, 36, 34, 33, and 35 is about general health. Okay, so on and so forth. And for then we also have questions about mental health, like vitality, social functioning, role emotional, and so forth. Okay, here this is an example of a scale. So what happens when you have this kind of scale? Basically, they already decided to study this factor, you must have question on this item. So, for example, you want to study about physical function. You must ask whether the patient can walk a mile or not, can walk several blocks, can walk one block, can can bathe or dress on his own, okay, can live or carry groceries, climb several flights of stairs, and so forth. So the item that you ask questions about is related to the thing that you're studying. Okay, so this is the example uh, of one such scale to measure quality of life. Okay, so in the basic concept is, okay, an instrument such as your questionnaire, you are creating it to measure something that you cannot usually measure. To measure something that you cannot usually measure. Here, it is what we call a latent trait. A latent trait is something that is latent, something is that is there, but it cannot be measured by a ruler, by a weighing scale, or anything like that. So, for example, in this scenario, what if we want to measure physical fitness? So, you come up with items that is related to measuring physical fitness. Okay. So, here is a list of similar examples as before. These are some of the examples of measures of fitness. Okay. So the lowest level, the easiest thing that people should be able to do yourself, bathing or dressing yourself. Okay. Then kneeling, bending, stooping. Yeah. For some of us above 50 years old, maybe this one is a bit tough. Listing or carrying groceries. Okay. Nowadays, I find that it is easier instead of ordering groceries by going to Giant, I order it online. So the postman, the courier will send it to my house directly. No need for me to leave or carry groceries. Okay, walking one block, climb one flight of stairs, walking several blocks, climb several flight of stairs, moving a table, walking a mile. Okay, this morning I just walked 2 kilometers, so that's a bit more than a mile, so I'm okay. So, or vigorous activities such as running, or strenuous sports like cycling 160 kilometers, doing the Ironman, so on and so forth. Okay. So as you can see, we have a scoring method here: 1, 2, and 3. So since we have a scoring method of 1, 2, and 3, we can see clearly that those who are not limited at all, they get the highest mark. Those who are limited a bit, they get lower mark. Those who are limited a lot, they get very little marks. So the lowest possible marks here is 10. The lowest possible marks here is 10. Why? Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 questions. So the lowest marks is 10. The highest mark is 30. The highest mark is 30. Okay? 3 times 10 is 30. Okay, so these items are combined to measure a single factor or latent trait here, which is fitness. Okay, so let's try to score for yourself. So you can see bathing and dressing yourself, no problem. Bending, kneeling or stooping, got some problem. Sembayang pun sembayang duduk. Okay, so you got 2 marks. Lifting or carrying groceries, no longer young like before. Okay, you can carry, but after that you end up with chest pain, so no point. So you put a bit limited. Walking 1 block, no problem, 1 block only. Okay, climbing 1 flight of stairs, climbing 1 flight of stairs, tough a bit. Okay, walking several blocks, that one a bit further, limited bit. Climb 7 flight of stairs, 7 tingkat, 7 flight of stairs, cannot. Okay, so limited a lot, so forth. So this one, when doing all this scoring, you come up with score, and the final score here is 19. So this is 19. So is this good or is it bad? You're not sure. Okay, but you know 2 is the neutral score. So 2 is the neutral score, somewhere in between, in the middle. So when you divide by, when you look 2 by, okay. Wafa asked, did not do the scan. Don't worry, we'll put up the scan later. Okay. Uh, so sorry. Okay. So you have the cut-off point. So how to have the cut-off point? It is very easy. You get the maximum possible score minus the minimum score, divide by 2. So maximum possible score is 30 minus minimum, which is 10. So you get 20. 20 divided by 2, you end up with 10. Then you plus back the minimum score. So plus back minimum score is 10. So the cut-off point, the neutral score is 20. So therefore, the score of 19 is below the cut-off point. Okay. So then you have to check the relativity of the composite score, whether it's reliable or not. So you can check it by using Cronbach alpha. Okay. So, but this one is very pertinent. Very pertinent. How can you score them up? How can you sum up all the scores to come up with one global score? Because you have to understand, when you ask the question, each one of them at one time, okay, so each one of the response are ordinal nature, because they are strongly disagree, neutral, agree, strongly agree. So these are ordinal response. They are not really measurable. They are not really something that you can take a ruler and measure. Okay. So can you sum up the score to come up with one global score? Is the final score, is it ordinal data or is it interval in nature? Okay. And the other thing is, each item measures a different level of fitness. How can you give them equal weightage? For example, the question about being able to bathe yourself. Being able to bathe yourself. Okay. And the question about being able to do Ironman. The scoring is same, 1, 2, and 3. How can they be the same? Because bathing yourself is something very easy to do, and doing the Ironman is something very hard to do. How can you give the same weightage? Okay. And of course, the other thing is, will the instrument be reliable and valid? Okay. So for that, we have to validate. So there is an increasing demand for psychometric skills in the health field for measuring things that cannot be measured in the usual way. Therefore, skills in the health field need to have excellent psychometric properties, including reliability and validity. You do this a lot. You do on quality of life. Okay, we look as though we are confident that this thing is the ultimate in measuring quality of life. But is it really true? Is the response that you get, okay, is really measuring the quality of life? Okay, so you have to make sure that the tools are really measuring what they are supposed to measure. Okay, so these are things that cannot be easily measured, but now you are trying to measure by using instruments such as questionnaire. Okay, so why use Rasch? Rasch is, well, as mentioned earlier, last Tuesday, it is item response theory. Okay. Usually when we want to validate a questionnaire, we use exploratory factor analysis and confirmatory factor analysis. But Rasch is also possible to use to validate a questionnaire. Rasch believes that when they do the item response theory and they converted the response to become logit, the ordinal score has been converted into interval score. Okay, we already covered this earlier. Okay, so I'm not going to go in detail yet at this point, but we may cover that later. Okay, so there are a lot of these Rasch models. We already covered last Tuesday about dichotomous Rasch model. So today we're going to cover partial credit model. Partial credit model and rating scale model, the approach is similar. The only difference is for partial credit scale, the patient's response, the ordinal scale is not the same from the start to the end. For rating scale model, the Likert scale is the same from the start to the end. Okay. Then we have binomial and Poisson model, the many-facet Rasch model, and multidimensional Rasch model. The one that I'm familiar with is only dichotomous Rasch model, partial credit model, rating scale model, many-facet Rasch model, and multidimensional Rasch model. For the binomial and Poisson models, I'm not that familiar with. Okay, but anyway, I'm going to cover only the partial credit model for today. Okay, these are the explanation. Okay, on which one to use for which analysis. As mentioned now, dichotomous is for yes or no, or success or failure. Okay, for rating scale, questionnaire type survey with Likert scale. Okay, for this exercise, I'm teaching you all so that you understand enough about validation of instrument, so that when you have your project for SKM next semester, you can do the appropriate analysis. Okay. So the aim here is to do EFA and Rasch credit, partial credit analysis, and because it is best to use the same data set, so you all understand. The same data set will be used for both EFA and Rasch. And for this analysis, we have 10 items on physical function and 5 items on mental function. Okay, here is the data set. Okay, this data set consists of 117 complete data set. We have question physical function from 1 until 10, and question of mental health from 1 till 5. Okay. Okay, where can you get this data set? If you go to drtamil.me, my website, drtamil.me, as you can see down there below my name, there's a scrolling text. And the scrolling text is stating that my website is drtamil.me. You click on FK6193. You click on FK6193. You can see on lecture number 4, CL4, Rasch partial credit. So click on that one, you'll get this page. And this is the data set. Physical function, mental health. There are 170 data set here. And then we also have all the data set meant for Rasch analysis. Okay. So feel free to use this data set as we are going through the slide. I'm not going to demonstrate today for a very simple reason. It is not possible to cover this topic in one sitting. Okay, so therefore I'm not going to cover it today. So instead I'm just going to cover the theory part only. Okay. All right. So let's look at the physical score. So let's look at the physical score. As mentioned earlier, there are 10 questions. Okay. So here are some example about scoring for physical. Okay. The example, they ask you, can you jog or not? Can you climb stairs or not? Can you dress yourself or not? Can you go to the wedding ceremony in your neighboring house or not? Okay. So the answer is 1, 2, and 3. 1 is limited a lot. 2 is limited a little. 3 not limited at all. Higher score indicate higher physical capability. and the residents are supposed to, residents, the respondents are supposed to score 1, 2, 3 only. Okay, so what are the 10 questions? Okay, for the real truth is I do not know what was the real questions for this data set. So I'm just guessing. I'm just guessing. So we have question number 1 for vigorous activities, number 2 is for moderate activities, 3 for lifting groceries, 4 for climbing several flights of stairs, 5 for climbing one flight of stairs, 6 bending, kneeling and stooping, 7 is walking more than a mile, 8 is walking several blocks, 9 walking one block, and 10 is bathing or dressing yourself. Okay, so that is the okay. So here are the some of the data set. Okay, as you can see from the data set, okay, there are these responses. There are these responses, and based on these responses, we do the analysis. So okay, so we have the question number 1, number 2, number 3, number 4, number 5, number 6, and so forth until question number 10. Okay, they score themselves 1, 2, and 3. Okay, they score themselves 1, 2, and 3, and these are the total response. Okay, please take note. Please take note. 117 complete data set. This one, some are 117, some are more than 117. So those questions that everyone completed, 117. There are some questions that have more than 117, but they did not complete all the questions. So the only one that is complete are the 117 questions. So that is for the physical function. For the mental score, okay, I did check and I found out there are 9 questions for mental score, and there are positive scale, there are negative scale. Question 1, 4, 5 and 8 are supposed to be negative question. So negative question means the higher the score, the worse off you are. Okay, the worse off you are. The higher score, the worse off you are. The other one, the positive question, the higher the score, the better you are. So we have these questions 1, 2, 3, 4, 5, 6, 7, 8, 9. Question 1, 4, 5 and 8 are negative question. Question 2, 3, 6, 7 and 9 are positive question. Okay, so we assume based on the data set that we have, these questions are really the positive questions. So it is question 2, 3, 6, 7 and 9. So in summary, are you nervous or not? Are you in the dump or not? Are you feeling blue? Are you worn out? Do you feel tired? So you can see these are the responses. Okay, now the sum for this one, the one that covers every complete data set is only 110. It's only 110. Okay. Okay. So all these things are being summed up to combine. Sorry, all these are 8 questions are being combined to create a single factor or single score for mental health. Okay, let's do the first part. Let's do the reliability analysis. These are all classical test theorem. Classical test theorem. Okay, we covered this last Tuesday. We have the Kuder-Richardson formula 20, KR20. It was published in 1937. It is a measure of internal consistency and internal consistency or reliability for measures with dichotomous choices. This one we covered already, so I'm not going to cover again. And this one is Cronbach alpha, which is a measure of internal consistency for measures with ordinal ratings such as Likert scale. Please look carefully. The formula are the same. The formula are the same. Okay. Okay. But this one is P times Q. This one is rho squared. Okay. The rest are all the same. Okay. So this one, the rho squared is for each item, and this one is for all the score. Alright. So that is the formula on how to use Cronbach alpha. Okay. The argument with the Cronbach alpha is if they are all measuring something similar, like fitness, all these things are highly correlated with one another, and therefore they are pointing in the same direction. Okay, so Cronbach alpha can be used to check the reliability of the composite score and will identify which items have a problem in forming the composite score because they were pointing in a different direction. Okay, so you got 10 questions, all 10 questions is pointing to the right. Okay, then no problem. But if you have 10 questions, 9 items are pointing to the right. Okay, but another item is pointing down in a totally different direction altogether. Therefore, they are not measuring the same thing. They are not measuring the same thing. Okay. Okay, so the data for this lesson you can download from here. What happens when you click on that link, you end up going to the same website I showed you earlier just now. So don't worry. Okay, so let's go to the next slide. Okay. Right now, I really not sure what's happening on the Facebook. Hopefully, everything is going well over there. Okay. Let's check out the Facebook. Okay, it's still going on. Ada seorang tengok, Alhamdulillah. Okay, saya tak tahu siapa yang tengok. Just say hi, tell me. Okay, who's there? Thank you for watching. Okay. Okay, let's look at the slide. Okay, let's look at the slide. Okay. So right now I'm looking at 6 screen, the num screen. Okay. So in this case, for the Cronbach alpha, it is very easy to do inside SPSS. You just download the file, the physical function mental health.sav. You click on analyze, scale, reliability analysis. Then you run the Cronbach alpha for physical function and the mental health separately. What to click? You click on statistics, then you select everything that's there. Okay, like item, scale if item is deleted, and correlations. Okay, so you will get these answers. You will get deleted, but in fact there's only one part of the whole thing, the Cronbach alpha. Okay, internal consistency. Okay, now I'm seeing my background a bit here. Why? I had to put up my screen because the sunlight was falling on it the wrong way. Okay, never mind. Okay, so let's go back to the lecture. Okay, so you can see here all these items are highly correlated with one another. They are all highly correlated with one another. If you're looking at this one, the corrected item total with the correlation, corrected item with the total score. And in terms of correlation, you can see the score is all above 0.45. Here on the right side, the Cronbach alpha if item is deleted. You can see here 0.869. If any of these items were deleted and they end up with a better Cronbach alpha, means the question should be omitted. So you can see here, they are all become much less if the Cronbach alpha is, if the Cronbach alpha become much less if the item is deleted. So we have to keep these items. So conclusion, our Cronbach alpha is very good. Our Cronbach alpha is very good. 0.869. Okay. So please take note, since 2 is the neutral score, the mean above neutral score means that people score higher. So you can see here, this one, everything is higher except question number 1. So question number 1 is very hard for people to achieve. Okay. The order of easiest to endorse as 3 to the most difficult. Sorry. So the easiest is PF5 and the toughest is PF1 in terms of order. Okay, so looking at this, so wow, it is not expected. Okay, the easiest is climbing 1 flight of stairs, not bathing or dressing yourself. Okay, and the toughest is still walking a mile and vigorous activities such as running or strenuous sports. Just imagine lah, bending or kneeling or stooping is tougher than lifting or carrying your groceries. Okay. Just to highlight, okay, this one by right, because this is ordinal scale, you should not be using mean. Okay, but since we are just explaining based on the classical test theorem, we just use mean so that you can see how the trend is like. Okay. Okay, now so we're going to look at the item total correlation. It is the Pearson correlation between the scores for the item and the average of scores of the remaining items. Okay, so this is the character item and the total correlation. You can see the higher the ITC, the higher the association of the item to fitness composite score. So which one is got the highest score? 0.651. So question number 9. Okay, that one got the best association with the fitness score composite. Okay. If there is any value larger than 0.869 in this column, I mentioned just now, then the reliability is better without the item. So here, that thing did not happen. Okay. So basically, if you do the correlation between the total score of all items or the response of the respective item, they are quite similar. For the corrected item total correlation, okay, and the total physical score correlation with each of these items. Okay, they are quite similar. So corrected item total correlation, as mentioned earlier, is the value without it. Okay, Pearson correlation between the scores for the item and the average score of the remaining item. So you got 10 here. The 9, what is the score like? Okay, so that is the meaning of that. Okay. So for mental health, same thing happen. We run the analysis. We find that there is a problem we want to question. Okay, why? You see here, Cronbach alpha 0.658 means this is not very good. 0.6, you remove question number 5, it becomes better. You remove question number 5, the questionnaire becomes better. So how about it? Is it 0.658? Is it okay? Minimally acceptable. Minimally acceptable. So what you should do, you should add more items to improve reliability. and get rid of the question that is causing problem. Like here is question number 5. Okay, question number 5 is the problem question. Okay, so you can see here the item total correlation is very bad, 0.197. Okay, by removing the Cronbach alpha, you will improve the Cronbach alpha from 0.658 to become 0.719. So we should relook at the question. So question number 5, maybe the question is not really measuring mental health. Maybe it is really measuring physical function, because they say, do you feel tired? So tired could be something physical, it could be something mental. So maybe it is not clearly determined, so therefore the question is not suitable to be there. Okay, so that is the scenario. So the last item is too general, not specific to depression or mental health. Therefore, MH5 should be changed to something more specific for depression or mental health. So that is the example. Okay, are we done? Not yet. We are not really done yet, because that one is not the final part. The one we're just looking at the Cronbach alpha. So Cronbach alpha just looking at internal reliability. Now you have to look at the exploratory factor analysis. So we are going to do the exploratory factor analysis. Okay. I'm having a lighting problem, so I'm bringing more light to the room. Okay, much better. Okay, so now my background is much better. Sudah hilang all that dark spot. Okay. Jeng 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 jeng. Okay. So exploratory factor analysis is a tough topic. Okay, usually I allocate 1 hour just for this. But today, since we are covering a lot of things in just 2 hours, so let's see what we can cover within that short time. So under SPSS is under analyze dimension reduction factor. Okay, so you will select all the buttons on the right side there, your descriptive, extraction, rotation, okay, setup and options. Okay, wait, no, not setup, save. Okay, I'm getting messages, I don't know why. Okay. Okay. So you click on all these buttons. We click on KMO, Bartlett's test of sphericity. On the extraction, you click on correlation matrix. You select eigenvalue larger than 1. Iterations for convergence is 25. Okay. Then for the rotation, we take Varimax. We want the rotated solution. Again, the iteration for convergence is 25. You click OK. Okay, you will get answers like this. Okay, what do we look for? Okay, we look at this KMO measure of sampling adequacy. KMO measure of sampling adequacy should be larger than 0.6. Right now here we are okay because we got 0.776. Next, we look at the Bartlett's test of sphericity. Bartlett's test of sphericity indicate that you are not measuring only physical function in one dimension. You have more than one dimension here. So the Bartlett test significant means you have more than one dimension for the physical function. Okay, so what happened? Okay, so you are going to look at each one of these items, and then they say, okay, wow, you have two dimension. what are the dimension? Okay, so turn out we have one is the dimension for physical function, the other one is the dimension for mental health. Okay, so please take note, earlier for the reliability analysis, we analyze physical function and mental health separately. For exploratory factor analysis, we do it together, and when we do it together, the EFA tells us that the questionnaire that we have measures two different dimensions. So one dimension is the physical function, the other dimension is the mental health. Okay, okay. How do you know that they are as so and so? Because you can see that for physical function, they are highly correlated with one another here. For mental health, they are highly correlated with one another here. Okay? Okay. So this is the, based on statistic, we should have 4 components. Okay, 1, 2, 3, 4. This is where it level off, so we take the earlier 4. But because we know the questions only measure mental and physical function, okay, there's only 2 domains. Okay, we should try to force it to become 2 domains. Okay, we should try. So what we do? We set at the factors to extract only 2. So when you say only 2, they give you only 2, and suddenly you see physical function all gang with physical function question, mental health all gang with the mental health questions. Okay, the 2 factors support our design as 2 domains. Items in each domain are correlated with items in the same domain, but they are not correlated with items in the other domain. Okay, so this one correlated, this one correlated, but only with their respective component. This is component for physical function, this is component for mental health. Alright. Okay, and this is how we present the results. Cronbach alpha is 0.87 for physical function, and it is 0.66 for mental health, and these are the mean, standard deviation, and item total correlation. But of course, as mentioned earlier, having the mean and standard deviation is sort of heresy. Why? Because you know the responses are ordinal in nature. Therefore, ordinal data you cannot use. You cannot use mean and standard deviation. Okay, maybe it should be omitted, but the convention is to report everything like this. So who am I to say which is right, which is wrong? Okay, that is how we validate using reliability, from alpha, and using EFA, exploratory factor analysis. Okay. Yeah.
Nak tanya tadi kan masa yang Prof buat KMO tu, dan untuk yang physical punya question, bila kita buat tu kita akan dapat factor 1, factor 2 kan?
Okay.
Maksudnya kalau sepatutnya, maksudnya dalam question tu dia ada 2 group, betul tak Prof? Bukan yang paksa ni, yang sebelum tu.
Okay. So sebenarnya the real fact is when we do it,
Dia ada 2 group kan?
when we do it statistically, this is what we call when we do it statistically. Secara statistiknya ada 2 group.
So maksudnya
soal
2
group.
Dalam soalan tu ada 2 group kan?
Soalan untuk physical function ada 2 group. Soalan 1, soalan 2, soalan 7, 8, 9 satu geng. Question 3, 4, 5, 6 and 10 satu lagi geng.
So maksudnya kita kena paksa dia supaya kita dapat satu factor untuk physical, satu factor untuk mental, macam tu kan?
Sebab kita tahu kita punya soalan ni, we know that already our question is supposed to measure physical and mental. So we are just forcing it together. Kita paksa sebab kita tahu dia sebenarnya memang untuk physical function. Tapi kalau you kata, okay, I nak tengok lebih mendalam, adakah soalan 3, 4, 5, 6 ni ukur a different kind of function? Mungkin soalan yang ni ikut different kind. Ikut two kind of function. Satu adalah, ni kita dah tengok soalan ni. Satu set soalan ni mengukur kekuatan. Satu lagi set soalan ni mengukurkan flexibility. Jadi kekuatan dengan flexibility ni berbeza. Jadi itu sebab kita ada dua yang berbeza. Tapi kalau sebab kita nak memudahkan perbincangan, kita nak combinekan dia jadi satu domain yang sama, kita boleh paksa dia. Okay. So ada dua choice. Either you can continue to analyze it as two separate domain under physical function, or you can analyze it as one physical function. Alright? Okay. Thank you for the question.
Prof,
Yep.
kalau pilot test ni berapa macam ni kita nak tahu kan, kita sebelum kita nak validate tu kita kena ada buat pilot test. Berapa ramai kita nak buat pilot test tu supaya KMO ni betul.
Okay.
Sebab certain tu saya pernah buat Prof sebelum ni, and then saya buat dalam 20 orang je, and then bila saya tengok balik journal, dia kata macam sample size tu terlalu sikit untuk buat pilot test ni.
Itu that topic would have been covered by Prof Azma. I think Prof Azma ada mention about having at least 5 sample per question, something like that. Am I right? But on my part, okay, there is another set of notes that I did not share earlier, because your group is different. Your group is the one we just explained, so that you know enough to proceed with the SKM project. But for the real group that are really doing the analysis, there is another set of notes where we cover the questionnaire development. Okay, so when you cover the questionnaire development, we even show you at each step, at the pre-test, pilot, how many samples. Okay, there is another set of notes you can check nanti. Can I show it to you now? Okay, I tunjukkan kat mana notes tu Okay. Okay, the notes are, okay, so you can see here there's reliability and validity analysis, number 5. Okay. Sorry. Dia tak keluar lah. Kejap, try sekali. Dia tak keluar. Let's see whether this one keluar. Okay. Ni keluar PowerPoint je. Kejap. Okay. Okay. Dekat sini. Learn advanced steps with Ayub. Okay. Password dia lean9. Okay. Okay, thank you. Okay. So inside here got all the notes. Sorry. Okay. So I'm not going to cover that here now. Okay. Okay, that one cover all the different stages of developing a questionnaire. Okay, and how to pretest it. That one we cover in next semester. We're not covering it here now because we are just going to go through about the concept. So don't worry about that. Okay, we already covered until this slide. Okay. Okay. So we're going to cover Rasch. Okay. So as stated just now, okay, we already covered the CTT. CTT is the classical test theorem. We covered using Cronbach alpha, and we covered using EFA Exploratory factor analysis. So this one is Rasch partial credit. Again, we are doing the same questions. Why we call it partial credit? Because as you saw, the fitness questionnaire got 3 scale. The mental health got 5 scale. Okay, or was it 6? Can't remember. Okay, so they got different Likert scale. Therefore, we call it partial credit. If they are the same, 5 and 5, then it will be rating scale. Okay, so under Rasch, they also do all this. They do response format, they do model fit, they do internal consistency, item bias, DIF, and targeting. This is done separately for mental and physical items. Then we have for dimension like EFA. Okay, EFA, what they call here is PCA, Principal Component Analysis. Okay, and see whether it got one dimension or two dimension. Okay. The next 1 hour is going to be super laju and super blur. Why? Because we're just covering Rasch, something totally new, but I will do my best to explain it clearly. Okay. Okay. Again, the same slides here. Okay. So please take note, you can download the slide from this link. Okay. You click, you get the slide. Okay. For Rasch, the same way what we did with dichotomous, how they measure the marks are based on logic. How they measure the marks are based on logic. So you can see here, they look at how many you answer 1, how many you answer 2, how many you answer 3. Okay. Okay. So then they will come up with the logic. Okay. The formula looks like this. Okay. For the, okay, I don't know whether you saw that. Up here you see? Okay. What is the score that you get? Then maximum possible score minus that score. So here, the score is 30. Maximum is 30. So 30 minus 30, you get 0. That's why for this 1, 2, 3, 4, 5, 6, 7, you cannot get the logit because they are divided by 0. This one, okay, we have the score of 29 divide by maximum minus score. So 30 minus 29, you get 1. So you get a logit of 29 divided by 1. So that's why when you do the logic, end up with value of 3.367. Okay, so on and so forth. So this is how you do it manually. But again, as I said before, we have a software. The software will calculate the item response theory for us. Here, like in this one, it is the ability index individually. For the item, again, it is the same way, but terbalik, but the other way. This one is maximum because some people answer, some people don't answer. Okay, some people answer the question, some people don't answer the question. So you can see that here 37, 61, 24. The total is not the same for each row. Okay. That is why these numbers are not the same always. Okay. So that is how. Sorry, that's my wife. Nasib baik tak mati heart attack. Okay. Yeah. Okay. Alright. So that's clear. So that is how we got that one. Okay. So now you can see if you look at the mental and physical function just now, this is the R squared. Okay. You can see that there is some correlation there. Okay. Okay. There are some terminology here that is very difficult to understand. To be frank with you, the first time I attended the class, they talk about infit, outfit, mean square, ZSCD, root mean square error. I said, what the hell these people are talking about? Okay, so just take note, infit, it refers to information weighted statistic. Outfit is unweighted statistic. Mean square is the mean square of the statistic divided by the degree of freedom. So how much it should be? Oh, sorry. Aku tengah ngajar. Aku ngajar sampai pukul 12.45. Masalah apa? Dan tak boleh buat apa. Tak ada green screen. Okay, alright. Okay, bye. Very sorry. When there's some changes of schedule and I'm teaching right now, so nothing much I can do about that. Okay. Okay, so we covered this already. Okay, let's look at the physical scores. Okay, let's look at physical scores. Okay, so when we run the analysis for Rasch, this is what was generated. Okay, this is what was generated. So when we do this is what command is this? This command they call it 3.2. Okay, what is the point here? Because we have a Likert scale. Okay, we have a Likert scale. So they are trying to look at the Likert scale, whether you're supposed to use 1, 2, 3, 4, 5, or you're supposed to use 1, 2, 3, or 1, 2, or whatever. So here, for the physical function, we got a Likert scale of 1, 2, and 3. So Likert scale of 1, 2, and 3. So you can see here, you have 1, 2, and 3, the scoring. Okay. So you can see here that there is what we call the separation. Okay. The separation between the scale is larger than required. Okay. So, okay, what is meant by larger than required? Between this value and this value, and this value and this value, the separation should be 1.4 or less than 5, stated here. Here you cannot measure because there is none. So, but here you can measure. Here it is 1 minus 1.12 and here is 1.12. So 1.12 and 1.12 it is 2.24. So it is larger than 1.4, therefore it is okay. So the rating is okay. So what does it mean? It means that people who are answering 1, 2 and 3 can clearly differentiate what is meant by 1, what is meant by 2, what is meant by 3. So you can see here, there is a clear separation. There is a clear separation. So this is what they call the Hendrix threshold. So the Hendrix threshold, it is 1.12 for here. Here is minus 1.12. So the distance between here and here, it is 2.24 logit, larger than the required 1.4. So since it is larger than the required 1.4, we are okay. Okay. Doktor tak faham? Memanglah kau tak faham. Okay. But what I'm going to say here, if you get Hendrix threshold value, the separation, larger than 1.4, your Likert scale is okay. Your Likert scale is okay. Okay. Alright. Okay. I'm very sorry because I just realized there is another group. Okay. Sekejap, give me a few minutes. I need to set up the other screen. Okay, because right now I'm running two monitors, one on the right side, one on the left. Okay, the one on the right is running the Zoom for the department session, Okay. Susah, susah because you will end up having to do 2 or 3 things at the same time. Okay, never mind. If that thing happens, happens. It does not happen, what to do? Okay. Okay. So let's look at the model fit. So the trick is right now, we look at the infit ZXCD. The infit ZXCD should be close to 0 and the mean square should be close to 1. Okay. Okay. The mean square should be close to 1. If it is larger than 2, got problem. Okay. Larger than 1.5, got problem. So the only thing is okay is 0.5 and 1.5. Okay. So that is what is meant by that. Okay. Uh, sorry. Nothing much I can do about that. Okay. So I'm going to give up on the other one. Okay. I'm just going to handle you all. God gave us only 2 pair of hands and only 1 pair of eyes. Oh, 2 pair. 1 pair right and left hand. So you cannot really handle 2 computers at the same time. Okay. Okay. Alright. So let's look at what is meant by that. Let's look at the values. Okay. You see here, when we run the Rasch analysis, we end up with this what we call the fit statistics. So this fit statistics, okay, this fit statistics is what is generated for you automatically. So this fit statistic, you look at the value, you can see that the infit mean square is 0.95, which is close to 1. So we are okay. The ZXCD is close to 0. So we are okay. So for both the person and item, they are both okay. So both are close to 1 and 0. Okay. So that is how we look at it. Okay. Okay. I managed to get the other thing to be running. Yeah. Yeah. No problem here. Tak boleh juga. Okey, susah. Okay. Okay, sorry about that disturbance because basically I'm also recording on the right side. Okay. Okay. So let's look at this thing. Okay. So we already talked about infit and outfit. So let's go to the next one. So the other thing we look is for the questions. So we have 10 questions here. Question 1 till 10. Then we look at the Z STD. Anything that Z STD larger than 2, it means question got problem. Then you have to omit it. So here you can see that there's no Z STD larger than 2. So we are okay. For the person that took the again we look for Z STD larger than 2. Again we don't have a problem here. Okay. Okay. So then next step is we are going to try to see whether we can see the Cronbach alpha, internal consistency. The Cronbach alpha under Rasch is not direct. Okay, the Cronbach alpha and the Rasch is not direct. So how do you get the Cronbach alpha? Okay, it is based on a long-winded method. Okay, a long-winded method of trying to get Rasch. So okay, so it is based on G. The G is what we call person separation index. How we get the person separation index is based on the true SD divided by the RMSE. Okay. Doctor, what is RMSE? Okay. You remember back this one? It is the root mean squared error. It is the root mean squared error. Okay. When you look at this data, okay, you get the root mean square error, the RMSE. So based on the RMSE, okay, where it is down there. Okay. So you have the RMSE. So and you have the standard deviation. So based on the standard deviation and the RMSE, you end up with the G. Based on the G, you can generate the R. Okay. And based on the G, you can also generate the strata. The how many this one we covered earlier last Tuesday. The strata is how you can divide into how many groups, so on and so forth. Okay. So let's look at this. How to calculate manually. Okay. Okay. 1. Okay. So remember, person separation is index G is the true SD divided by the RMSE. Okay. So you have the okay. So here you can have the value. If you're looking at the other way around, okay, you have the relativity index of 0.8, the Cronbach alpha 0.8. Okay, you put in the value, you can get a G of 2, and for the G of 2, you can get a strata of 3. So the higher the reliability, the better it is, because you can divide the group into larger group. Here, you have a reliability of 0.9, you end up being able to discriminate into 4 or more groups. Okay, so here I show you how it is done. Here I show you how it is done. First, you have to generate the G. How do you generate G? You look at the true SD. So here you have the true SD, 1.65. Divide by the RMSE. Okay, so you have here 1.65 divided by RMSE. You get 1.67. So 1.67 is the separation. So this is the G, the separation. The G, the separation, can be used to generate the R. The R is the reliability. So here the percent reliability, the G, is 0.736. You can see here, it is 0.736. Based on the separation, you can split the data to show that it can be used to separate your group, your respondent, into 3 groups. Okay, so that is how Cronbach alpha is calculated inside Rasch. Not the same like the way we did earlier using the SPSS. Okay, so in short, okay, you can see here, based on the summary statistics, you get the same output, which is 1.71 G and the strata of 2.61. Okay, so this is just an example. All right. This one was from where? This one from the last week one. Hello. Yes. This one is from the question. Okay, you can see here. Okay, you have 126 piece, respondent measured. It's from this. You got 10 questions, and that's why you get this kind of data set. Okay, so this one 1.66. Okay, this one 1.71. Okay, similar. The only difference is this one you are getting everyone here. Okay, this one they just take the one who are not, because you got extreme and non-extreme measure percent. So this one 126. I think this one is much less. Okay, because they remove the extreme ones. All right. Okay. So this one is when they remove the extreme ones, and they can generate the the G in the G, the Cronbach alphas and so forth. I'm not going to worry about that. This one just explanation about the same thing, that what we did earlier, how we generate the G, the R, okay, from the Rasch analysis. Okay. Okay. So let's not worry about that. Okay. Any question? Here's Fatin Hamimi. They're off mic. They're on mic. Anything? Tak ada. Alright. Okay. Okay. Alright. So let's not worry about that. Okay, this one is one part. This one is just because for us, we just want to know the reliability index, the R. Okay. Then we go for the item, same thing. Again, the G is based on the SD and RMSE. You put in all the calculations. Same thing happen here. Based on the fit statistics, you end up with separation of 5, G of 5. You have R of 0.961. So very high level of reliability. Okay. Okay. Next. Okay, DIF I'm not going to cover, so we cannot do it here. This one is okay. Next, there is such a thing, we call it a variable map under Rasch. So under variable map under Rasch, when you do the map, you can see that we have the item on the right side, we have the person on the left side. So for the person here, you can see that there are about 49 of them who got the score of 3 for almost on all the questions. So these people are not properly assessed by the item, because even the most vigorous activities such as running, lifting heavy objects, and participating in strenuous sports, they can do, no problem. Things that are very easy for them to do: bathing or dressing yourself, climbing one flight of stairs, they find it very easy. So you can see here the question. Okay. So these are the targeting of the questions and the person. So based on this, if we want to really measure the fitness level of everyone here, you have to set up more questions. You have to set up more questions that can measure their level of ability. Okay. So maybe can set, can you run 1 kilometer in 5 minutes, so on and so forth. Okay, so you can measure the higher level of fitness. So in short, the physical questions were okay. Why? The most important thing, the Likert scale are okay. Separation of 2.24 legit. Okay. There is reliability of 0.73. For item 0.96. And the targeting shows that items and person are well targeted. Okay. So when we do it side by side, you can see that the Rasch and the SPSS agree with one another. But of course here for the Cronbach alpha, okay, they just give a 0.87. Here they give 0.96. Why? Because this one is really based on the person's response. Here they just taking only for the items. Okay, that's why it is much higher. Mental score. Mental score, same thing. But this one a lot of problem. You remember back mental score, you got a score of 1, 2, 3, 4, 5, 6. We found out the scoring of 1, 2, 3, 4, 5, 6 got problem. Why? Respondent cannot differentiate. Respondent cannot differentiate. Respondent cannot differentiate between 1 and 2. Respondent also cannot differentiate between all the other values. So what happened now? We need to merge some scales. So we have to merge data, they become better. Especially under Rasch, it's very easy to recode. We just come out with this line of coding we put in inside. Automatically they recode the data, and the analysis is done, completed, one go, only at the text level. Okay, immediately you can see that the new skills are okay. The separation are much better. Okay, you can see minus 1.7 and 1.7, it's already 3.4. So yeah, okay. Separation are okay. Okay, you can see separation are okay. 1, 2, and 3. Okay, so not only Rasch detected that respondents were having problem trying to answer 1, 2, 3, 4, 5, 6 for the mental health question, they also provided the solution. If this is a pilot study, when you do the full study, you're going to have only Likert 3 response to format. But since this is a full study, we already collected data, we just run the further analysis using the recoded Likert 3 response datasheet. Okay. So all this following data is based on the Likert 3. So you can see here, everything is okay. The ZSD is okay, close to 0. Mean square is close to 1, so we are okay. Apply for both item and person. Person is 0.99, minus 0.1. Item is 1 and ZSD is 0, so we are okay. Questions 1, 2, 3, 4, 5. Again, the ZXTD for question 5 got problem. The Z is 2.3. So question 5 should be changed or removed. Okay, so again here, anything larger than 2 should be changed or removed. Okay, you can see here, these are the problems. Okay, these are why we have problem, because mostly because, as I stated earlier, the questions are very hard for people to answer. Okay, we look at internal consistency, we already covered this. Okay, this is the RMSE SD separation percent reliability, and you can see it has very, very low reliability, 0.47. Very sad, but very low. So for the item, again, we have item reliability of only 0.6, so we have a problem there also. Okay, so let's not look at this. So we do targeting. You can see the 5 questions here are all lumped together one place. Wow. So problem. So when we have like this, because they are not properly distributed out, so this question can only measure this small group of people. They are not measuring the rest. So right now, these 5 questions are not enough. you have to come up with more questions. Okay, so conclusion, mental health KO. Mental health, the questionnaire are not very good. Have to do a lot of repair. Okay, so again, similar results between SPSS and Rasch. Okay, finally, I know you all are suffering right now. You can hear it in the silence. Doktor, cukup lah. Okay, this is the toughest part. This is the toughest part. This one is, if you don't get it, I understand. Not many among the Rasch practitioners also can comprehend this very well. Okay, this is the principal component analysis of residuals for the Rasch analysis. It is different than the PCA under SPSS. Okay, because you want to see whether they are unidimensional or multidimensional, we will put in everything together. Why? Because we see a lot of people, they have this global score for quality of life. So is it really true that you can have a global score of quality of life? Okay. So you need to check that all items share the same dimension, and this will help to this analysis will help to identify the secondary dimensions. Okay, and maybe if it is true there are more than one dimension, it is better to divide into two measurement instruments. So under Rasch, you have the Rasch dimension, and Rasch dimension is your explained variance, which is ability index and difficulty index. Okay, then you have the unexplained variance from the residuals. They're looking at the unexplained variance, whether it is random or whether there's any other effect. Okay, so the principal component analysis under Rasch, they try to decompose the unexplained variance. We are going to look at the first contrast and see whether there is a secondary dimension or not. If the first contrast is larger than 2.0 eigenvalue, we will look at the cluster 1 A, B and C versus cluster 3 A, B and C. So if it is true, there may be a different dimension. Okay, then if it is proven to be two dimension, then you will do a separate analysis. Okay, so this is for the quality of life for that 15 questions. Because there are 15 questions, the raw unexplained variance automatically become 15. Okay. When you run the analysis using Rasch, they automatically generated the person person measure and the items measure. Okay. Okay. So total, we have the total raw variance in observation, which is this one total. The raw variance explained by the measure is M. Raw variance explained by persons measures P. Raw variance explained by items measure, that is I. So this one is already generated by Rasch automatically. So by right, these two P and I already mentioned, explain everything, and it should be part of this. But now, suddenly you have the unknown. The unknown is so big, which is 15. Because we got 15 questions. So we look at the each items. Okay, we got four here we got 5 components or 5 contrasts. So each one of the contrasts we got 3, 2, 1, 1. Okay, and these are the value. So this unknown is the sum of all this. Okay, the sum of all that. So 1, 2, 3, 4, 5, 6, 7, 8, and we have the others which are not explained. So 8, there are 7 more. Okay, so there's a total of this one. Yeah. Okay, so that is how we look at it. Okay, so okay, Right now I'm hearing a lot of noise. The noise are coming from Microsoft Teams. I also don't know what's causing the noise. Okay, never mind. Okay. 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 So what do we do? Number one, we look at the in the past, the raw unexplained variance explained by measures, we want this to be 40%. So if this is 40%, you say the model is good. Why? Because everything can be explained by the person and items measure. Here cannot. It's only 35. But under the new school of thought for Rasch, 35 is still okay. In the past, we prefer it to be larger than 40%. Why 15 as mentioned just now? Because we got 15 items. But now the bigger issue here is the variance in the first contrast. We have it 3.09, which is larger than 2. So since it is larger than 2, chances are we have issues of multidimensionality. So we look at this table. Okay, we look at this table. What table is this? Okay, this thing is all under table 23 under Rasch. This thing is all under table 23 under Rasch. You scroll down further, you get this one. Cluster 1 versus cluster 3. This is the cluster 1 items. This is the cluster 3 items. Okay. So you can see that this vertically defined contrast. One cluster is close to the intended dimension. The other cluster is off dimensional in a major way. So satu dekat, satu lagi jauh. Okay. So when we have this kind of situation, okay, we look at the next table. And the next table, again under table 23, but this is 23.1. Sorry, 23.2. You can see automatically they say the problem is your data set has 2 dimensions. And what are the 2 dimensions? We have cluster 1 and cluster 3. So here you can see here, these are the cluster 1 items, the 5 questions. And if you look here, they are all questions of mental health. If you look here for cluster 3, they are all questions of physical function. So cluster 1 is mental health, cluster 3 is all physical function. They are on separate dimension. They are measuring separate things. Because of that, okay, you have to analyze the data set as 2 separate dimensions. And this is proven when you look at the, I don't know what happened to it. Now we will select at 120. Ayo. Okay. Okay, so we have to run the analysis for PCA separately. So we run separately for physical first scores. You can see that. You can see here, these are for the physical score. There are 10 questions. So raw unexplained variance is 10. You can see that for the raw variance explained by the measures is 9.9. Okay, 9.9. So let's see how much is that in percentage. So 9.9 is 49.7%. So we are good. This is not 50 and this is 10. This is 10 because we got 10 items. This one is larger than 2. We need to look at cluster. Okay, I just realized this one salah. So this one is supposed to be 10. Sorry. So you can see here, cluster 1 and cluster 3. They are off, but they are not off in a major way. They are off in a minor way. Okay, so we got two set of questions here. So you can see question physical function are really two dimension. Okay, one set of dimension is for easier task. Another set of dimension is for the tougher task. Okay, but it is smaller than but it is larger than 0.3 and it is unidimensional. Okay, okay. If you look earlier, Allah, slide 100. If you look earlier at slide 100, 100, 100. Sorry, I'm very sorry. If you look, remember back, this one for the physical function. Okay, this is less than 0.3. Less than 0.3 other secondary dimension. The one that we got is larger than 0.3. So it is unidimensional. Larger than 0.3, so this is unidimensional. So although this one shows that there is two, okay, but the two are off in a minor way, not in a major way. Therefore, you can use this analysis as a single dimension of physical function. No need to separate it into two separate dimensions because they are the same thing, but only one is measuring easier, the other is measuring tougher event. Okay, so dimensionality testing suggests that physical function is a unidimensional and could be used as an individual subscales for fitness. Same thing for health, mental health. You can see here. Okay, as mentioned earlier, MH5 is way off. Okay, so let's look at this. This one, first contrast 1.7, so we okay, it's less than 2, so not really an issue. So no need to look at items in class 1 and 3, except it is unidimensional. So unexplained variance in the first contrast is less than 2, therefore it is unidimensional. Okay, and sorry, I don't know what happened, but they keep going back to that slide 55. But you can see already we are done. We are done. So it's larger than 0.3, so we are unidimensional. Alright. Okay. So in short, quality of life as a total scale should only measure one concept, quality of life. And they should also have a subscale, which is because they are also unidimensional, which is physical fitness and mental health. Okay. You can look at them separately, but you cannot combine them using a global score. So in comparison between EFA and CFA, EFA did an adequate job of validating the instrument. Rasch partial credit analysis did an even better job, not only in detecting the problems within the data and the items, but also on the response moment, the Likert scale. And they also give the solution so that you can complete the analysis. Okay, Allahu Akbar. This thing keep coming out. I don't know why. Okay, alright. And with that, the final slide is about references. So the notes are from Prof. Lin Nang. He's on his talk on advanced biostatistics. We have notes from Zalim Muhammad he was conducting trainers on Rasch measurement analysis. I did use some books. One of them is from Benjamin Wright and Geoff Masters, rating scale analysis. This book is available online if you want to search for it. I also referred to Lineker's book on V-step analysis for this purpose. Okay, and with that, these are the team members, the Rasch Malaysia Association. Okay, and they provided me with the necessary training so that I can analyze data using Rasch. Thank you very much. Alright, so I think we can stop here. Right now, I know you all are traumatized. My apologies. My apologies. The trauma must be horrible. You all may need some counseling after after this. Kindly consult the
Speechless.
nearest psychiatrist. Yes, Farid. Anything, Farid?
Speechless, Prof.
Huh? Speechless.
Speechless.
Okay, let's go back and summarize the whole thing. In summary, that we have questions. We have questions. And when we have these questions, the argument are the questions measuring what they are supposed to measure. And are they all in the same dimension? Or are they all measuring the same thing? So any new questions that you came up, you have to validate. And when you validate, you can use all these different methods. And you can escape by just doing a Cronbach alpha and say, oh, I have validated my questionnaire, my Cronbach alpha is so and so. But in real truth, not only you have to do that, you have to do all the other testing to show that your questions are measuring what they are supposed to measure and whether all the items inside the questionnaire are all on the same dimension. Okay? So that is the whole point of this exercise, to show you that you can also be asked on validating of your questionnaire. Okay. So Fatihah dah tanya soalan. He answered her online. Okay. I need to shut down my Facebook. Okay. Today Facebook, dia orang traumatized. Tak ramai orang attend. Okay. So bye-bye Facebook.